So I want to show you a fascinating infinite series that has a result that you might not expect. So here I've got 1/2 plus 1/4 plus 1/8 plus 1/16. And if you keep going infinitely, continuing to cut the denominator in half, and you add up that sum, what you're going to get is 1. And I want to show you a way to illustrate that. Let's suppose that I have a 1 by 1 square here. Now, obviously, the area of that is 1. But let's suppose that we divide this square into two parts. Okay? So now we've got the area is 1/2 plus 1/2. Well, that's 1. So dividing it the way we didn't hurt anything, and we still have the same area. Let's suppose that we divide this 1/2 down here into 1/4. So now the area is 1/2 plus 1/4 plus 1/4, which is also 1. So see, the area is still 1, but now to get the area, it's 1/2 plus 1/4 plus 1/4. Now let's divide one of these. Divide that fourth into 1/8 plus 1/8. So now look, 1/2 plus 1/4 plus 1/8 plus 1/8, that's 1. So we can go a step further. Let's divide one of these 1/8 into 16ths. Divide them in half. And you notice now we could talk about the area being 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/16. That still adds up to 1. And we could keep doing this. We could divide this 1/16 into 1/32, then 1/64. But the point is, the sum, this infinite sum here, adds up to 1. Now, another way to illustrate this is if you look back here. Let's suppose, let me move this out of the way. Let's look at this sum. We've got 1/2 plus 1/4 plus 1/8 continuing forever. And we know it equals something. I'll just call it S. Now, let me do this. I'm going to multiply both sides by 2. Okay? Now, if I multiply both sides by 2, this 1/2 becomes 1. This 1/4 becomes 1/2. 1/8 becomes 1/4, and so forth. So I multiplied both sides by 2, and notice I've got a 2 over here now, 2S. So here's what I've got now. I've got this 1, this 1/2 plus 1/4 plus 1/8. All of that is just S, as defined up here. So I've got 1 plus 2S equals 2S. A little bit of algebra gives us that S is equal to 1. So yeah, that sum equals 1. This is just one example of why infinite series are so fascinating.